Hi.
Hi.
So please introduce yourself.
Yeah, my name is Gang Xu. I work for Jingce Electronics in USA, and we published some papers this year. And for this one, we are doing test instruments and testers. So that's why This paper is about a Demura for OLED panel. And the key requirement for OLED panel Demura is you have to use white image and capture that with camera. And the requirement is preferably you do one single shot for one gray level. That really optimize your test time. And what we're doing differently than other people is with white image, we are using monochrome camera. Other people are mostly using RGB bare color camera. But by using monochrome camera, we optimize the light efficiency. You don't waste light energy from the color filter. So the key requirement for using monochrome camera is since your display white image has RGB different color dots, you have to separate these color dots from white image. So what we do is we build RGB color filters like here with RGB and the clear color filter. Clear means just no color filter. So when you do this, when you use the display, do the Demura, you capture the white image at high gray level and apply color filters to generate the red, green, and blue. That you effectively separate these color dots. And once you get this colored image, single color image, you do a binarization. You generate what we call masks. These masks really memorize the locations for each of the red dots, green dots, and blue dots. So once the masks are generated, you can apply the mask for all lower gray levels, because most of the test time is spent on the low gray level. You need to collect photons, so you have to wait long time. That's why you choose not to use RGB color filters. You just use the white white one. So this way you really optimize the test time.
So where does this process go in a display? Is it for testing display, making the display, or?
This is a testing display.
Testing.
And the display always has some uniformities when you make them. So what we do is we measure the non-uniformity at the sub-pixel level. So we know the difference between this dot and the next dot.
Is it a quality control to check which one is grade A, B, or nothing to do with that?
You could do that. You could use that, but most of the time, customers use this to do the compensation. When the display is made non-uniform, and they warp the image to compensate for the hardware defects, then what the result shown on the real image shown to the viewer will be perfect.
So the software or the chip, the rendering engine has information about the defects to compensate automatically forever.
That's right. We measure the non-uniformity or the defects. Since we are an instrument company, we measure the non-uniformity, and then we send the data to the customer. They decide what to do. They have their own algorithm to do the compensation.
It was very interesting for me to hear how the micro LED tile display with all the little borders and the little small maybe problems, and they do some compensation to the pixel to try to make it so the eye don't see it.
Yeah.
And is the same stuff for OLED?
Yeah. The OLED actually has more requirement for pixel level compensation.
More requirements.
Right. And
because
more
it's organic.
Because the OLED suffers pixel level non-uniformity more than LCDs. LCD, what they call Mura, it's usually area-wise. But with OLED, you could have a pixel level non-uniformity.
And does that mean every super nice OLED display people buy now, each of them have already some compensation? Every single one on the market?
Yeah, just different vendors, different makers may have different compensation method. And then some people really do a lot of compensation, some people doesn't care much and just do very little.
And cheap it for cheap.
Right.
But when the OLED is more expensive, it means the people compensated correctly.
They spend a lot of time and then they have to put a lot of memory to try to approach a perfect compensation.
And nobody does it, the detection like you do? This is a unique way to do it?
No, other people are doing this, but they are using different approach. And what unique for us is we are proposing using a monochrome camera. Other people are using color camera.
And as you were explaining before, by doing monochrome, you recognize differently.
The key issue by using monochrome is you have to, from white image, you have to separate red, green, and blue. 3 channels, you have to separate them.
But to me, it just looks because they have different shapes, but it's nothing to do with shapes.
You could. Some people try that. They say by using different shapes, but you have to recognize different shapes to this detail. You have to use a lot of very high resolution cameras. Usually, that's too expensive.
So this can be done very quickly?
Yeah,
for the whole display?
Right, for the whole display, and we can use somewhat low resolution color filter resolution cameras. So this is what we call mapping ratio. 17 by 17 means for each color dot we use 17 by 17 camera pixels to map this. But we try to lower the requirement and to 3.5 by 3.5, even 2.4 by 2.4, and we proved our method gave the same result. So you can use low resolution camera.
Is there a good compensation for dead pixels, or dead pixel have to be?
That's already done.
That's easy to do.
That's done years ago.
And then there's some pixels lower intensity and higher.
That's also done years ago. But if you are talking about single dead pixel or single bad pixel, what they call weak pixel or bright pixel, and those things were done years ago. But this is done for non-uniformity for all pixel level. This is, say, grid level. So this signal is 100, 101. This is 99. They try to make them even.
Does it make sense to calibrate and recalibrate displays after the time damages the blue pixel or something, and you want to scan it again?
Usually not for non-uniformity. Good question. Usually, uniformity-wise, it's not that bad. But if you have a defect one, right? When you do the compensation, you have a bad pixel. You make the surrounding pixels a little bit brighter, so you see less of this effect. But in this case, you could disproportionately burden the good pixels around it, and over time, that kind of thing could happen. But I never heard that in-field, once the panel display is sold, right? In-field calibration is very tough.
You cannot just load an app on your phone and put the camera of the phone to load your software?
You need a camera.
A different camera than the phone camera, something specific?
Yeah, of course, because the phone camera doesn't see the phone's panel, right? Display panel. Maybe you can use a mirror, and you have a good design. You can file a patent. Use a mirror, use a phone camera.
All right. To see itself, you mean?
Right. Can you see itself?
Yeah.
Maybe using a mirror.
Okay.